Today we're going to continue on with transportation planning. We're going to be looking at trip generation and move into transportation analysis zones then. Again, remember this is chapter 8 in our textbook, so if you want to read through that, you can kind of keep up with where we're at on that. So this is out of the textbook, actually. The chart is out of the textbook. And last time we talked about transportation demand modeling is modeling human behavior, which makes it kind of fun, but also difficult, trying to track, essentially if you think about the neighborhood you live in, we want to know where everybody in that neighborhood is going and how many trips a day they're taking and what routes they're going to use. I mean, that's the goal in the end. If we know that, which is a lot to ask, if we know that, we can figure out how many people are driving on the road in a certain spot. If we care about road traffic, or how many people are taking the train, or how many people are taking transit, right? Depending on whatever mode choice they use is. Now, the book, in their chapter 8 in the book, they focus mostly just on road traffic because it's mostly highway based, I guess, is what their focus was. But just remember, it could be other modes as well. So I'll try to broaden out some of their discussion to cover some of the other modes as we go through that. But this is their example, and here is, if you work from top down to the bottom here, trip generation, this is where everything starts at, right? We're starting up here with trip generations, and we're going to move through until we finally know what we want to know, which is traffic flow. We want to, in this example, that's what they're trying to get to, is how many people are actually driving on the road, right? And we've done a lot of work so far in understanding how traffic works and how to calculate levels of service and how traffic signals handle the traffic, and so this is we started, I guess, more in the weeds, and now we've moved up to a larger view, right? And so this more encompassing view is how many people can you expect to be on this road, right? If that's the whole point of demand modeling, is trying to figure out and predict how many people are going to be using whatever facility you've got, how many trips are going to be made through that. And this is kind of their flow. So trip generation starts up here with where are people coming from, right? How many trips can we expect them to make? And the book does kind of an interesting job. I haven't seen this too often before in travel demand modeling. Focus on what time are they leaving, right? So if the peak hour, it makes a difference. A lot of more regional models and 20-year future models look typically at a full day, how many trips per day, right? But if you're looking at a near-term model, it is more important to know what's your peak hour flow, right? We can always estimate peak hour flows. We know that's somewhere between 8 and 12% of the total ADT. Typically is what it is, right? But they did a good job of pointing out that certain trips commonly happen at different times of the day. Work trips, standard work trip is more between 7 and 8 a.m. would be your peak in the morning, and 4:30 to 5:30 in the afternoon would probably be your peak on the return trip for work. Whereas shopping trips don't usually start at between 7 and 8 in the morning. They're going to start later in the day, right? And recreational and social trips tend to be in the evenings, right? So there's the peaks of those different trip types are at different times of the day. So that's an interesting piece they talk about in the book through there. And they kind of condensed the mode choice because we're just talking about highways in this. But in the traditional travel demand modeling, we would talk about mode choice a little more strongly, especially where there is transit options and ped and bike options through there. So I think the college campus is a great example that, from the west side of campus, if you're in the residence halls over there, it's pretty easy to walk to campus over to Gellerson. It's easy to take your bike to Gellerson. It's also easy to catch the shuttle, right? You actually do have pretty good mode choice on campus, about how if you're going to take a trip all the way across, right, through there. And mode choice, the funny thing, that's an interesting point too, is weather will affect your mode choice, right? During a storm, you're going to more likely to ride the shuttle over if you don't have a car, right? Or if you do have a car, you're more likely to drive it versus walking if it is really nasty out through there. So that's interesting piece too. We have to calculate into that mode choice through there. And they're focusing on highway trips, and so if we know where people live, if we know this is a residential subdivision, right, that's going to be a place where most of these trips originate, right, through that, because that's where people live. That's where they're starting out, and that's their base. And we'll talk about, what we consider the base. Later, there's home-based work and so forth through that. And so where are they coming from? How many trips are there going to be? What time is their peak, basically? Is what we're worried about. Are these at 7 in the morning or are these at noon? Right, it makes a difference. And finally, where are they going? And that's a whole other section we're going to get into, which is the destination piece of it. And then finally, that should all boil down to, once we determine what routes they're going to take, if we know where they're going, how many cars are on the road at a certain point. And so that we're starting at up here of trip generation, and what we want to get through all this, we want to end up with what's our ADT, what's our traffic number on the road, because that's what we're trying to plan for. Right? If we're using the highway as an example, a highway project as an example, that's what we want to get to, is how many cars exactly, or exactly as close as we can, but what's our relative number of vehicles that are going to be created from this, right? So if you build a brand new subdivision on the edge of town, how is it going to affect traffic in town, right? And which roads are going to have see the biggest effect? Those are our classic uses of this travel demand modeling piece through there. And remember, we talked before about this is the traditional 4-step method coming through here, which is trip generation, distribution, mode choice, and then finally assignment. Distribution is where you're figuring out where people are going to. So trip generation is this zone creates so many trips. This is where they're going to. Here's the mode they're going to use to get there. Could be highways. Right, and then finally, trip assignment is putting you onto a road and assigning that trip to a certain route through there. All these steps are fairly complicated. In a serious model, in a major model, all of those steps are time consuming and have a lot of variables that go into them. Right, so none of this is easy through there. If you get to work on this later on, there's a lot of variables in each of these steps too, which adds into the kind of general, concept that this isn't a very exact science. No, it's not bad, and they do a pretty decent job, for what they've got. It's just not super exact, right? So just remember that too as we work through these. And so this is matching up that traditional 4-step model with kind of the sequence they have here in the book in that one table through there. This is, and to break it down, so this looks a little more general and big concept picture, right, through there, but think about you're in an individual house, or maybe this is what it all boils down to, is if we could track what you were doing all day, right, and then we can aggregate that for people in your same category, right? Students could be a nice category, right? Students who live on campus, here's their standard trips. And if we were to have a significant sample size, we could use typically linear regression analysis to figure out how many trips we should expect an average student on campus to be making, right, through there. Or in this case, this is kind of a working person, right, through there. And so they're leaving for work from home. They go to lunch, so they take a trip in the middle of the day to go out to lunch, then they go back to work, right, and then they finally leave work, come back home, then they go, after they get home, they decide to go shopping, right, and then they're going to go visit somebody. So this could be, you can see this would be a pretty standard day in someone's life, right? Well, so if we can get enough data about what people's standard trips are and how many trips they make per day, on a normal day, I guess, again, if we get that statistical sample size that we need, we can now equate this to, okay, well, this is a typical day for somebody who has lived by themselves and has one car and has an income level of X, right, and lives in a single family home, right? And so for everybody else in that same group of categories, maybe we can extrapolate and figure out, okay, well, this is a pretty common number of trips, and so we can expect other people and with those same conditions to make similar numbers of trips, right, through there. And that's where we try to break it down by that kind of grouping, and we're going to see that here in a second. But that's kind of I like this diagram because it just kind of this may seem a little too abstract, right? Number of origins of trips and how many trips you're going to take and departure time, right? It starts from here. It really starts from here. This is a sample of what someone's doing during the day, and we know this stuff. We don't. Google may be tracking us every time you use your phone. I don't know, but what we really know is. We send out surveys. This is how we find this out. We send out surveys. We ask people, or we ask them to be part of the study, and we'll put a GPS tracker with them, and then ask them to log where they went. And so that's how we find this out. They'll do a major MPO. They don't do this that often because this is very time consuming and very expensive, but this is how they generate this data. Is they actually do a study on people. And I think in the Chicago area, I think they had 10,000 people in their last study when they were trying to update their data. Right? Doesn't sound like a lot, but you can learn quite a bit even from 10,000 through there. It's just that each data point is very time consuming to collect and then to analyze, and that's why we don't do more of it through there. But that's where this comes from, right? And so the things to think about is do you as a student make the same kinds of trips per day as your parents do? Do you take more trips or less trips than your parents do, right? You choose the same kind of mode choice as others. Or if we want to compare college professors and someone who works at a store, right? Are we, even though we may live in the same neighborhood, where are we headed, right? That's trip distribution. Where are we headed, right? Probably different places. I'm going to campus, and someone who works at a store is going to wherever, probably a larger retail center, right? So they're probably going out there. It's more likely where they're going to head to where all the stores are, which is probably out there by Silhavy and LaPorte, right? So going to Target, or they're going to Menards or something like that. Whereas I'm going over to campus. So our distributions are different. What time would we go, right? College professors kind of show up whenever they feel like. So who knows what time we show up on campus, right? I tend to be more regular about it and get to campus between 8 and 8:30 if I'm traveling, right? Right now I'm just staying at home. So it's I walk over to the desk about 8 o'clock every morning. Whereas a clerk, their stores may not open until 10, so maybe they're going later, and maybe they work later, right? They don't get off work until 8 o'clock or 9 o'clock at night sometimes through there. And do we make the same number of trips, right? So again, think about that. Again, we're trying to do the best we can with limited information, but one way we can work through this is we can break things down by categories, right? And so we try to get similar groups. And so one way we do it is we can break it out by trip types and say, well, work trips, let's just look at work trips, right? Let's not try to go back and look at every trip somebody makes first, but let's just say, what is a standard person's work trip look like? And what time do they leave, and where are they headed, and so forth. So we can break it down by category that way, right? We also can look at by household types, right? If it's a single person household, the household has one person in it. Through there, their trip types are going to be different than a household with 4 people, because if it's a household size of 4, that probably means there's kids in it, and there's going to be school trips, and there's going to be more shopping trips, there's going to be more recreation and social trips, because we don't have that many trip types, and so we lump in like all the little league games and gymnastics practices and everything else into that social recreational category, right? So if you live by yourself, you're less likely to be doing all that, whereas you can picture, right, households with small kids, they do a ton of that stuff, right? When it comes out Little League season, they're gone every night, some of these houses through there. So that's again, if we can put these, if we can categorize things better and put them into bins, it's easier to predict the number of trips they're coming through. The other thing we look at is by geography, right? So people who live in this subdivision, where are they more likely to go? And how are they doing their trips? And quite often, if you think about the neighborhood you live in, they're quite often fairly homogeneous, right? There'll be big sections. Think about in Valpo. There's big sections that have apartment buildings. There's also big sections that are single-family homes. And then there's kind of mixed-use areas, right? And the groups of people who live in these neighborhoods tend to be fairly similar. And so a lot of times, yeah, we're breaking it down by single family homes and with, however many people live in those homes, right? But a lot of times that also fits into geography. We're going to get into that later today and how we use that geography piece to do modeling better through there. Or think about like a retirement home area, right? So there's these larger groups. I don't know what you'd call them, retirement centers, maybe is the right term, but they'll have a bunch of single family homes, and then they'll have some group living areas, right? So the assisted living, and then there may be a nursing home attached as well. But a lot of these, larger complexes, they'll have a bunch of duplexes and single family homes, but they're all retired people. You have to be retired to live there, right? There's no kids, and so their trip types, it can cover a number of acres, and quite a few people can live there, over 1,000. A couple of them I can think of have more than 1,000 residents in these retirement communities. I guess that's the right term, right? And so you can think of that, well, think about your grandparents. They live in one of those centers, right? The kinds of trips they and their friends make are probably pretty similar, right? They're not going to go to schools very often through there, but they're going to, and they're not going to work, right? But they're going to probably, dork around in the middle of the day when nobody else is out driving, right? You think, if you're ever out on the highways at 10 a.m. or 2 p.m., like there's a bunch of pokey drivers, and I'm thinking, during commuting times, most people are on it and they know where they're going and they're trying to get to work or they're trying to get home. Don't get in their way. In the middle of the day, that's when I find there's a bunch of more of the retired folks kind of out poking around. Right? So their trip types are very different, but by geography, right, they all live in this retirement community together. They have very similar trip types to everybody else around them. So that's another place where geography kind of fits into it. And I can kind of jokingly, I can think of the entire state of Florida might have that same trip modus operandi, I guess, of the kind of trips they take. Probably not, maybe just in winter, all the state of Florida may be very similar, right? And if we have these studies and we do some linear regression on it or some other data analysis types, right, we can classically come up with kind of an equation like this, that the number of trips coming out of a household is some constant. Right, so let's say we're doing shopping trips. I think that's the first example in the book. If we did shopping trips, all right, through there, we know that just on linear regression, right? This would be your y-intercept basically through there, and then we have some other factors that adjust how many trips are made through there, and this is for a given type I, right? There would be a different equation then for work trips, and there would be a different equation for social and recreational trips, right? So that's and we'd have a different equation for those. We could sum them all up and get the total number of trips from an entire zone, right, through that. And these characteristics could be those things we just talked about: income level, number of people who live in the household, number of vehicles you own. Those are some of the biggest indicators of number of trips made. All right, through that. And so there's some coefficient for each one of those characteristics as we come through it. All right, so if we look at shopping trips, so we did some linear regression. We had a study out there. We asked people to track the number of trips they took for a week. And then we came in and we analyzed all that data. And this is the equation we came up with. Is that the number of shopping trips per day for a household is equal to 0.2, right? So that's just our constant, that B naught. And so that's 0.2. And then people make 0.1 extra shopping trips times the number of people who live in their house, plus 0.02 times the household income in thousands of dollars, right? So we put people into bins that, okay, if the household income is $50,000, we take 50 times 0.02, in that case, through there. And then the number of vehicles owned, right? So we could add all those up. So we take this general equation. This is what it would look like. Here's the number of people in the household, the income level in thousands of dollars, and the number of vehicles in that household, right? So the more people make, the more likely they are to go shopping. The more people who live in the household, the more likely it is you're going to need to go shopping more often. So you're going to make more trips. And the more vehicles you have, the more likely it is you're going to take a vehicle-based trip through there because it's available. Right? If you don't have, if there's not enough vehicles and the vehicles at work, no one's making a shopping trip as long as that vehicle's at work. Right? With whoever the worker is in the family. So this is, we could plug that in, right, through there. So if we had 3 people with an income level of $50,000 for the household and 2 vehicles, we could expect them, if we plugged all those numbers in down here, right, we could expect them to make about 1.7 shopping trips a day. So that's how we use those equations, right? And I don't know if this is a realistic number or not, but it doesn't seem too far off, right? On average, think about your household, maybe more when you were in high school, right? When you were living at home, do you think you guys went and shopped 1.7 times a day, almost twice a day? Someone was going to make a shopping trip from your household? Yeah, especially once you had your license and could drive and had a car available to you, you might make one trip, and your parents might make a trip, right? And so doesn't seem too far out of line there. But this is how we get it, and then we would say of similar households that have 3 people and an income level of $50,000 and 2 vehicles, how many households in this one zone are like that or in that category? Right? If there's 10 households that are just like this, then we would say you have 17 total trips coming out of that zone. That's what we would do with that. And that's how then we would assign those 2 roads, and then we would get our traffic volume. And that's where we like to end up, right? So here's some other common characteristics we use to model, right, and that have been shown over time to have an impact on the total number of trips made. And these are the more common characteristics that we use for that. So here's population, right, which is number of people in the household. The household type, whether it's a multifamily or single family, right, apartment dweller versus having your own separate house, right, through there. Trip types are a little different. Based on that. Employment, are you employed or are you retired or you are unemployed, right? The number of trips you make, that has an effect on it. Income level has an effect. Population age, again, people in their 30s and 40s with kids are going to make a lot more trips than older people. And I don't know, I'm not sure if single 20-somethings make more trips than family groups or not. Through there, it'd be an interesting piece to look at. What modes are available, right? You're not going to take transit modes if there's no transit available in your neighborhood. So we talk about that later on a little bit more. A little bit of his network capacity, ease of use. And so if it's very congested, if it's very hard to get anywhere from where you live, then it's less likely you're going to make trips, right? And finding vehicles per household. And really population, employment, income, and vehicles per household, I would say those are probably the most common characteristics we use. They have the highest weighting factor to them as making a difference to that. And I'm not sure why that came in late. And jumping back, right? So we said, well, we try to break things into similar chunks, right? We try to get a homogeneous look at an area, and then we can better model what it's doing, right? So if you think about these larger housing tracts that are all single family houses, they tend to be people tend to be this similar age, right? You can look at some of these neighborhoods; they kind of go through cycles, right? When it was first built, everybody who moves in is like a young family. That is pretty common. 20 years later, all their kids are in college, and then 30 years later, it's all just the parents left, and the kids are gone. And then it usually starts over. Then they'll start moving into retirement homes or moving off and to Florida, and now it starts over again at young families. It's kind of interesting to watch. Like if you've lived in an area long enough, that kind of works. Well, this geography fits into that as a piece, right? A similar neighborhood by housing type and so forth quite often has similar trip generation numbers, right, through there. And so geography is an interesting piece. We're going to move into that now and look at that a little more. We call those transportation analysis zones, or TAZs, through there. And we try to base things off of that because this geography does fit in very well with being able to split out what kind of trip types we've got, right? So how do we figure out what's a good transportation analysis zone, right? What's a good way to break that out? We try to keep the number of residents in a TAS, between 1,200 and 3,000, right? We don't want them too big. The bigger the zone, the fuzzier, I guess, your numbers are going to be, right? The less accuracy you're going to get out of it through there. And so it's a trade-off. We don't want them too small because that's too many zones. It's really hard to calculate, and it's a lot more work, and it takes a lot longer for the model to run. Even on a nice computer, it takes much longer. But we don't want them too big either, because we want some resolution. We want to be able to see things at an appropriate level of resolution, which typically we want to be able to predict cars on collectors and arterials. Is kind of where we end up with through there. So this is a rule of thumb. We try to keep the number of residents in a TAS between 1,200 and 3,000. Right, that's kind of a trade-off through there. That each of these zones has about 15,000 person trips per day or less. Right, we don't want too many trips out of that. Otherwise, we should, if it's a high-density zone and there's tons of trips, we want to break it into a smaller TAS so we can model it better. And the size of these is about a 1/4 mile to 1 square mile. Right, through there. If we need detail, we have to use smaller zones, so we have to improve our resolution through there. But the more zones we have, it's harder to build, and it takes a lot longer for the models to run in the process through there. And we tend to like them. Don't make these TASs like really long and skinny or weird shapes, right? We're going to show you in the middle, we actually are connecting the centroids of these zones, and so a very elongated shape is not going to be a very accurate way to model the traffic coming in and out of it. All right, so here's an example of a regional model, and this is around a single town. Each of these numbered boxes is a transportation analysis zone, and on top of that, they've overlaid what all the highway network is around it. And we typically, quite often, we'll use the road like in here as a boundary for that through here. And this is a pretty classic model. Down here, this is probably the downtown area, and so it has smaller zones because the density is higher. There's more people trying to get to downtown and working in downtown and so forth. So to model how many people are going to be driving on this road and then this road to get to downtown, it's good to have these smaller zones down here. Right now, where the housing density is less, like out here, right? This may be more of a rural situation, right? Or make our zones bigger. There still may only be, 30 people who live in this zone. There may be, 150 who live in this zone, households, all right, through there. And so that this based on that housing density, we can make these bigger and still, keep our limits, near similar through that. All right. So again, we'll use these larger zones where we have a lower population or less details needed. There's not any major roads passing through 71 out here, so we can make this as a bigger zone. And it's a little bit odd shaped, but it's still fairly. The centroid is going to be here. It's not too far from any of the outer boundaries of that zone itself. All right, through there, and then we use these smaller zones. We have dense population and more detail is needed, and then we'll use highways and rivers as a boundary quite often. You can see we have, sometimes we don't. Down here, this is actually passing right through one of the zones, right through there. That's okay. Quite often we will break it right on the highway as long as it works with all those other considerations to take into account as we go through. All right, here's the Chicago regional model, and so this is their zone. This is the actual zones they've got, and obviously Chicago is very concerned about because it is so large, right? That how many people are coming into downtown Chicago, and so people will come from a long way, right? We're in Porter County. And so we're down here, right? This is Porter County right in here. I think this is Lake, and then this is Porter. And I think Valparaiso is like this zone right here. I could be wrong, but it's something like that. Right? People from Valpo do commute to downtown Chicago. And so they're mapping how many people are coming in. They don't care that much this far out. right? This is LaPorte probably. They don't care this far out about any real resolution or accuracy. What they care about is if you came out of this zone, how likely are you to get to here, right? And then we'll have a close-up here in a second of what downtown Chicago looks like, right? So where they want more accuracy, we have smaller TASs, analysis zones, right? Where they really just want to know how many people are coming from here, and then as they get closer to Chicago, they care more about that resolution, right? They don't care exactly how many people are driving in and out of central Valparaiso. You couldn't tell from this size of zone. They're caring how many people came from Valparaiso and are going to end up in Chicago, right? Because as they get into the road network, the freeways, and the transit around Chicago, that's when they start caring about those numbers more so. So that's where the zones are smaller, right, through there. Here's an example of the downtown loop area, right? They've broken this into a number of little analysis zones all around there, right? This is what, probably 3 or 4 blocks square, I would say, in the Chicago road network through there. And so that's where they want the resolution, because they're worried about how many people are driving in here on Lakeshore Drive, right? Or how many people are coming up on Interstate 90, coming in from Valparaiso and then turning off and ending up in one of these grids. That's what they're trying to model. Or how many people are riding South Shore in up here, what about here, to Millennial Station, and then getting off and walking over to where? In the loop here, right, through that. So they've got much higher resolution here. And think about it, there's big buildings here. There's a lot of people working in one of these little 4x4 block grids through that. Whereas over here in Valparaiso, this is what the regional model is showing for Valpo through there, right? They don't, for their purposes, just knowing that you started inside the city of Valparaiso and you ended up here, that's good enough, right? They don't need to break Valparaiso into smaller pieces. They don't care that much. But they do want to know, where someone who lives in this blue box, that route they would take to get to Chicago is going to be different than someone who lives in this box, right? You're going to take different routes. Yeah, that's the resolution they're looking for, and that's why they've got it split as they do. Most likely as we go through. So that's, and you can see that, okay, everybody who lives in Valparaiso on a big regional model like this, right? See, yeah, their travel patterns are similar enough, right? They are similar enough to be covered in that. Right through there. Like if you lived way out in this area here, your travel patterns are similar enough based on how you approach Chicago eventually, right? That's going to be close enough for them to work through there. And it's interesting how far out they look at. This is one of the bigger regional models through there. We've got our mapping agency is the Northwest Indiana Regional Plan Commission, and that's our MPO, right? Their model is not this vast by any means, right? They're just looking at Northwest Indiana, and I think it's like 4 counties are in that zone that they model through there. Because Chicago is such a regional player, and people do commute from a long distance to get there, they have a much a broader model that covers a lot more distance, right? Through there. And so think if you were those to do a model of Valparaiso, how would you break it into similar zones, right? What would you do to do that model? And if let's see if my pen works here. If I was going to break it in, right, here's downtown Valparaiso. Actually, here's downtown Valparaiso, right? And yeah, there's some density there. It's not Chicago, right? So maybe we would break this into a zone here. Maybe this would be a nice, don't do that. Maybe this would be a nice zone by itself. Maybe this would be a zone, right? So there's my downtown zones. This is all mostly residential, right? So maybe that could all be kind of its own zone out over here, right? Here's campus. That's a very unique kind of use, and so maybe we would break campus into its own zone like there. There's some commercial along here, so maybe I would put that into its own zone. Well, here's Lincoln Way. Let's break everything on Lincoln Way and Sturdy through there. This is residential and it's kind of broken up by the railroad. So that could be a zone by itself. Well, here we've got all this commercial, right? That we probably want that to be zones on its own. Down here, here's the Walmart and all that stuff, right? That could be its own zone, and I'd probably break it like that. This is all commercial. This is a residential, and this is higher densities. It's got that. Oh, go back. This has got the. Stop that. Whoops. All right. Well, I really made a mess out of that. Let's go back here. Start this over. There we go. I haven't figured out this pen very well. You have to keep clicking weird buttons, and it does weird stuff on me. But out here, right? So now, it's every time I push, it wants to move on. No, we don't want that. I think the problem is I'm not in pen mode anymore. All right. Apologize. All right, back in pen mode. So this is all, mostly residential up here, right? So that we could, as we get further out of town, we can make bigger residential blocks, right? This could all be probably great big block out there. Look at, this is all very low density housing, right? We can make that into a big residential block, probably make this one into another residential block. All right, the further out we get, we can make bigger zones. All right, and this one, I don't want it to be too elongated, so we can do it like that. So here's all of our little blocks. We got smaller zones as we get down toward downtown or around the shopping centers, right, through there. When we get out into the country, right, we can make, like a square mile into a single zone. There's not that, the density is very similar out there. So again, we're breaking it into kind of those similar pieces as we go. And then down here, we've got all this industrial, right? So how do you want to break industrial up? Right, that's a place people go to work, right, through there. And so you can see how we could break this into TASs, right? If we were just modeling Valpo only, we'd want a lot more zones than we showed previously when we had that regional model, right? So for Valpo, we could do this, and we can, if you want an even finer resolution to know exactly where people are going, right? We could break these into even more pieces, right? And smaller zones downtown, right, through there. So now we can model even better the traffic on the roads, coming into downtown. And we've got some commercial areas down here. We could block out through there, right, along US 30 and so forth. So that's how, one example of how you might break down the TAS zones for a model of just Valparaiso, right? Okay, so next time we will pick up again on travel demand modeling and do some more work on that.